Hello everyone, and welcome to Introduction to R, Part 11, Control Flow. Now up until now in this guide, we've been using built-in R functions to perform various tasks and arithmetic operations. In this lesson and the next lesson, we're going to start learning how to do programming in R ourselves. Now, you can go a long way doing data analysis and predictive modeling in R without ever actually writing any custom code yourself, because there are so many functions either built in or in packages that you can use to perform most of the common operations that you'll want to do. But when you start getting into more complicated tasks, you'll likely run into situations where you might want to write some of your own custom code to perform operations that you can't find in a pre-existing package. So these next couple lessons will help us do that. So at their core, pretty much every computer program in any language is composed of basic logical operations, and one of those core basic operations is known as if-else logic checks. So basically, that's programming your computer to check if some logical statement is true, do something, and if it's not true, perhaps do something else. So we'll start by learning how to perform those sorts of if-else checks in R. We'll start here by just assigning some new variables. So we're giving x the value 10, we're giving y the value of 5, and in R, to do an if statement, you just write the word if, you then put a logical operation within parentheses. So here we're checking if x is greater than y, and then the body of the check is within curly braces. So curly brace, if it is greater than y, it's going to print the value of x to the screen, and then you have a closing brace to end the statement. So when we run this, we see that x is greater than y, so that means this check is true, and it will then execute this code body, which will print the value of x to the screen. There we see 10 has been printed. Now I did break the code for the if statement across 3 lines here. In normal usage, you'll write if statements in R like this. So you have if and the logical check all on one line. Then you'll have the opening curly brace here. You'll have perhaps several lines of a body, and then a closing curly brace kind of at the bottom. At least this is what I see often, and this is what I tend to do. So if we run this, it'll just do the exact same thing, but this is a more nice way of formatting it. Now you can accompany if statements with else statements. So above, we just checked if something is true, do something. But you can also check if something is true, else something else, which means if the check is false, then you can do something different. So here we're reassigning y the value 25. So this is going to be larger than x now, which means our initial if x is greater than y statement, this will now be false. So that means this first body is not going to happen because this statement is false. And if we didn't add this else part, if we ran that, it wouldn't do anything. But if we add else and then a new code body, it means if that's false, we're going to do something different. So if it's false, this time we're printing y. So we know that it is false, so this will end up printing this value 25. There it is. And there's one final statement you can use in R with if-else blocks. Instead of just using if and else, there's also this else-if statement. So this basically allows you to make a long chain of logical statements where you can say, if something is true, do it. If not, which basically is the if-else, is like if not. So if else, do this. If else, do something else. And you can make a long list of things that check a bunch of logical statements. And if they're true, it does something. If they're not, it goes to the next one. So in this case, we're setting y to 10, which is equal to x in this case. We're saying if x is greater than y, it's not. Print x, so that will be skipped. If else, y equals x, and that is actually true because they're both 10 right now. Print x and y are equal. It'll print the string out. So this code block should execute because we did set them to be equal. And then we have a final else statement that will print y if y is actually greater than x, which it's not anymore. So this middle if-else statement should be executed. You can see it was, and this string was printed. So that's the basics of if-else constructions in R, and essentially every programming language has the exact same system of being able to say if something, do something. If not, do something else. That's common across all programming languages, essentially. And now we will go into for loops. So in programming, you often run into situations where you want to perform some operation many times. Say you have a list of customers in a data set. You might want to check whether each customer meets some certain logical if-else statement. Like if this customer bought more than 10 items, say true, and if they didn't, say false, things like that. For loops are a programming construction that allow you to perform operations many times. So now we'll show how to make for loops in R. You start with the keyword for, then you have parentheses, and inside the parentheses, you set up what sequence you are going to be iterating over. So in this case, we're saying for each item, this is essentially a variable that we are defining inside of this for loop. So it's just a name we're giving to each item we're iterating over. So for each item in, you put the special keyword in here, and then you have some sequence here that you're iterating over. In this case, we predefined a sequence of values that we can loop over. So we made my sequence and we just stored it, this sequence, which is each value from 0 to 100 counting by 10. So in this case, we're saying for every item in that sequence, and then you have the open curly brace, you have a body, which is what you do with each iteration, and then you have a closing curly brace. So in this case, our for loop is saying for every item in the sequence we made, we're going to execute this, which is just printing the item to the screen. So what this is going to do is it's going to print every single value in the sequence when we run it here. You can see that each value is printed, and since it's iterating through one by one, they're printed one on each line, because each of these is a separate execution, instead of having them all kind of printed all on one line like you would if you, say, just printed the whole sequence itself to the screen. Now, for loops include some special keywords that allow you to control how the programming language loops through the sequence. Essentially, there are ways of like breaking out of the loop or going on to the next iteration without executing all of the code. So we'll show how to do that here. So in this for loop, we're looping over the same sequence for item in my sequence, but in this case, we're saying if the item is less than 50, if the value is less than 50, we're going to say next. What this next keyword does is it automatically skips us to the next item in the iteration sequence and doesn't execute any code below it. So in this case, we're saying if it's not at least 50, let's just go to the next one, and we're not going to execute this print item. So in this case, all of the values that are less than 50 aren't going to get printed, but all the values that are greater will. So this will cut everything off, and it'll only print the values from 60 to 100 here. I was wrong. It's from 50 to 100 because it's strictly less than 50. So this would have to be less than or equals to if we wanted to not print 50. My mistake. And there's another keyword called break. And what that does is it exits the loop entirely when it runs. So in this case, we're saying for every item in the sequence, if the item is greater than 50, we're going to just break out of the loop entirely. And if not, we're just going to print things. So this is going to start printing the values starting at 0, 10, 20. But as soon as the value is greater than 50, it's going to break and exit the for loop entirely. So we're going to get the values from 0 to 50 counting by 10, and then we're not going to see any other one. In this case, substituting break in for next actually results in the exact same output, because next skips to the next iteration, and it will just keep skipping them. Break breaks out of it entirely, but we still see the same output, but what's happening under the hood is actually different. With break, as soon as we see a value greater than 50, it exits the for loop and doesn't run any of the other values through. But with next, it actually goes to the next one, checks it again, goes to the next one, checks it again, etc. So you're doing more computing with next, even though the output is the same. So in general, you want to be breaking out of for loops if you can, so that you don't do all that extra execution and computation. All right, so now we're going to learn about while loops, which are just a different looping construct from for loops. They essentially do the same thing in that they're looping over and performing an operation some number of times. The primary difference is that with a for loop, you're looping over a sequence of known length, so you're doing something a specific number of times. Like in the last examples, we were looping over a given array of data, and we knew exactly how many values were in there and how many loops were going to be performed. While loops are different because you don't specify how many times the loops are going to be executed. They keep executing forever until some logical check is made false or until you break out of the loop somehow. So that makes while loops a bit more dangerous to use in a sense, because a for loop we know will always eventually exit once it loops through every item that it's looking at. But with a while loop, if the logical check that you set up for the while loop never evaluates to false, and you never provide a way for the while loop to break either, the loop will run forever, and then your programming environment will hang and essentially crash your program. So it's one of the main reasons I think that programs end up hanging and crashing. So here we're going to show how you set up a while loop. We are assigning x the value 5. We're assigning this value iters 0. This is essentially just going to be a counter that's counting how many iterations of the loop we are making. It's pretty common with while loops to do things like this, counting iterations, since we don't know for sure how many iterations will be performed ahead of time always, like we do with a for loop. So here we're saying, while this value iters is less than x, we're going to perform this loop body. And we can see to start off with, the value of iters is only 0 and x is 5, so it is true for now, and as long as this is true, the while loop keeps running. So while that is true, we're going to print the string study to the screen, and then we are iterating the value of iters by +1. So we're saying iters is going to equal iters +1. So every time the loop executes, we're adding 1 to this value. That's a very common construction to have with loops, where you're iterating some value, and once it gets high enough, you can break out of the loop. That's one way of escaping loops and not having them loop forever. So what this should do is it's printing study several times to the screen, but once the value of iters gets larger than 5, it will break. You can see there, it printed 5 times, and then the value of iters was too large, and this logical check became false, and it broke out of the loop. Now, as we said earlier, you need to provide some way of breaking out of a logical statement. So in this construction, we're saying while true. Well, true is never false. So this is a check that will never be false. And if you do that, you need to provide some way to break out of that loop within the body of the while loop, or else you're going to have something that is a infinite loop and is never going to break out. So we're saying while true, we're going to print study, but then we're immediately providing this break statement that breaks out of the loop entirely. So I'll run that, and this will end up only printing study once because we break. But if we took this break statement out or commented it out like this, and we ran this, the kernel would crash and we'd have an infinite loop on our hands. We're not actually going to do that, but you always need to provide some way of making the check false or breaking out. Now, loops are a common way of iterating through, say, an array of data or a vector or something like that and performing some operation many times. But in data analysis, and in R in particular, you can often perform operations on entire arrays or vectors of data without having to loop through them explicitly. And that is what's known as doing vectorized operations. And if you can manage it, vectorized operations are much more efficient than making loops, because with a loop, say even on a array that's only a length 1,000, you're going to do an operation 1,000 times in a row. Whereas if you can vectorize that operation, you can do that whatever operation you're doing on all 1,000 values all in one fell swoop, which makes your code much more efficient. And R has a lot of built-in vectorized operations that can allow you to avoid doing explicit looping in many cases. So we're just going to learn about one of the most useful ones here, which is the if-else construction. So if-else is a function that is able to perform logical if-else checks on all the values in a vector all at once, instead of having to, say, loop through the whole vector one at a time and then performing an if-else check on each value. So first, we're actually going to show how you might do this with a for loop, just so that we can contrast it with how much better the if-else construction is. So you don't really need to look at this, but this is just initializing the random number generator. Then we are creating a vector of 25 values between -1 and 1. We have a for loop here. We're looping through indices in between 1 and the length of the vector, which is 25. So we're doing 25 loops. And then inside the loop body, we're storing a number, which is the value of the vector at that specific index. And then we're checking if that number is less than 0, set the value to 0. So essentially what this is doing is it's generating values between -1 and 1, and then we're setting all the values that are less than 0 to 0. So this is not necessarily a super common thing to do, but sometimes you might be doing things with data where you don't want any values that are less than 0. So this is just showing a way that you could loop through and set all the values that are less than 0 to 0. And it's not a super complicated for loop, but it's quite a bit of code to do something that's relatively simple. So we'll run this and then print the vector. We should notice a vector at the end that has a bunch of zeros in it and about half the values that were greater than 0 that aren't set to 0. That was kind of a lot of code to do something that should be relatively easy to do. So a quicker way of doing this would be to use the if-else construction. So we're going to do the same thing here, but use if-else instead. So we're doing the same thing, setting a seed. We're making a new vector of random values from -1 to 1. But instead of doing a whole for loop, we're going to use if-else. So how the if-else construction works is you use the if-else function, then you pass in a logical test on whatever sequence you're working with. So here we're making a logical vector with the results of my vector less than 0. So that will make a logical vector where every single value in my vector that is less than 0 is set to true. And then you put a comma. If the test is true, then the first value in here is the value you set. So in this case, if this check is true, we're setting the value to 0. So that's doing the same thing we did above. And if it's not true, comma, set it to whatever other value you might want. In this case, we're setting it back to the original value of my vect here. So this if-else statement will do the exact same thing as above, just with a lot less code and in a vectorized fashion, so we're not having to loop through each value one at a time. It's doing it all at once. If-else is something that's very useful to use, especially in data science and data analytics, because you'll often be working with fairly lengthy, say, columns in a data frame, and maybe want to do tests like this, and you want to avoid using for loops on such things as much as you possibly can, because it can take a really long time to loop through a long data set one at a time. For loops that run, say, 10,000, 100,000, a million iterations can get very, very long to execute. So it's always better to try to use a vectorized operation like if-else if you possibly can. So that covers all the basic programming concepts for this lesson. You can essentially write any program just using if-else statements, loops, and storing variables. Those are the core constructs that make up essentially all other computer programs and functions. But you may want to be able to reuse blocks of code that you write in a convenient way, and that's where functions come into play. So far, we've been using built-in functions or functions and packages a lot, but it's nice to, in some cases, write your own custom functions so you can reuse a custom bit of code over and over again if you need to. So in the next lesson, we're going to learn how to do that with Intro to R Part 12, Functions.